For this example, we're given a partial graph of a polynomial function. We're asked to find all the zeros of the polynomial function and then complete the graph. So let's take a look. We have the function f of x equals negative 3x cubed minus 4x squared plus x plus 2. And we can see that we just have part of the graph. We have an important part, though, because we can see that we have an x-intercept of negative 1. And we also see that the graph just touches the x-axis at negative 1. That means that x equals negative 1 is a zero of multiplicity 2. So we can use synthetic division to help us find the other zeros. So we have negative 1, which we know is one of the zeros or the roots, and we'll use synthetic division, starting with negative 3, negative 4, 1, and 2. We'll bring down the negative 3. Negative 1 times negative 3 is 3. Negative 4 plus 3 is negative 1. Negative 1 times negative 1 is 1. 1 plus 1 is 2. Negative 1 times 2 is negative 2. When we add 2 and negative 2, we get a remainder of 0, which we knew we would since negative 1 was a 0. But we also know that negative 1 is another 0, so we can do synthetic division again. We'll bring down the negative 3. Negative 1 times negative 3 is positive 3. Negative 1 plus 3 is 2. Negative 1 times 2 is negative 2. 2 plus negative 2 is 0. Now, let's look at this last line that we have. When we started with our original coefficients using synthetic division, right here where I have the arrow, this negative 3 was to the third power. When we divided by x to the first power, we end up with this line, and now our negative 3 is just to the second power. When we divide again, we're now at our third arrow, so this negative 3 is to the first power. So therefore, this last line really says negative 3x plus 2 is one more factor of f of x. In other words, I could write f of x as x minus my first root of negative 1 times x minus the next root of negative 1 again, times negative 3x plus 2. So this is really x plus 1 times x plus 1 times negative 3x plus 2. I just wrote it in factored form so that you can see if we set x plus 1 and set it equal to 0, we'll get a root of negative 1. Now, let's look at this last factor, negative 3x plus 2, and set that equal to 0 to get our third and final root. We'll get negative 3x equals negative 2, so x is equal to positive 2/3. That's an important piece of information. We know that x equals positive 2/3 is our third and final root. So we'll plot that on our graph, and we can finish the sketch by noticing that we can look at the end behavior. So when we look at the end behavior, we look at the leading coefficient. Since the leading coefficient is negative and the degree is odd, that means the end behavior is such that the graph will go up to the left and down to the right. In other words, it rises to the left and it falls to the right. So we know what the end behavior is going to look like. We can use one more piece of information to help us, and that is to find the y-intercept. We can find the y-intercept if we let x equal 0. So let's let x equal 0 and find f of 0. If we do that, substituting 0 in our original equation for x, the first term is 0, the second term is 0, the third term is 0, and we have positive 2. In other words, the y-intercept is positive 2. This is enough to complete the sketch of this graph. It's a polynomial function, so I'm going to put an arrow going up to the left. I'll make a smooth curve crossing through the y-intercept, and then passing through the x-intercept. And this is a complete graph of the polynomial function.